Well, howdy. Welcome to Special Angles. And what we're going to do is we're going to look at special triangles that allow us to determine exact sine, cosine, and tangent values. So I'm going to start, there's only two of these triangles. So I'm going to start with the one that we run into the most frequently, and it is an equilateral triangle. This is where it comes from. Okay, now in equilateral triangle, each angle is 60 degrees. So I know all these angles are 60 degrees. And what we do is we make all the lengths the same, and we make them all 2. Now, there's a reason I didn't write it on the bottom, and that's because we split this triangle into 2 equal halves. And we make these both right triangles. Okay? So in other words, we've taken this side, which used to be 2, and we split it, so it's now 1 and 1. And over here, we can work out the top 2 little angles, because it used to be 60, but it got split. So it's now 30 and 30. And the one thing that we have that's missing is this length here. So let me just redraw what we've got here. This is actually the triangle that we're interested in. Okay, it is 2 and 1, and that's 60 degrees down here and 30 degrees up here. We only use one side of this. This is where it comes from, but we're really only interested in this triangle here. Now we're going to use Pythagoras' theorem to get this missing side. So the hypotenuse is the 2. So 2 squared equals 1 squared plus the unknown side squared. So that's 4 equals 1 plus the unknown side squared. Take 1 away from both sides. And now I'm going to square root the 3. So that's what the missing side is. So this is root 3. So this is known as the 30, 60, 90 triangle. And there's only one other triangle. By the way, you want to be able to memorize these. So you really want to learn them because they're not going to be provided for you on any formula sheet. The other triangle is a little bit simpler. It's an isosceles right triangle, meaning that 2 sides are the same length. So we make them both 1. And we make that a right angle. And we take the 2 angles here are both 45 degrees. And again, we use Pythagoras' theorem. If we do that, the hypotenuse turns out to be root 2. So these are your 2 special triangles. Now, what you might be wondering is that's nice, but what good are these special triangles? So what I'm going to do is I'm going to show you these in action. So I'm going to clear off the space here. And suppose we wanted to determine something like an exact value. So let's make my first example. Determine. And let's say we want to know the cosine of 60 degrees. Let's go, oh, okay, cosine of 60 degrees. No problem. I've got a special triangle that helps me out with this. I'm try and draw it a little bit neater than I did before. Okay, that's not too bad. So I think, oh yeah, there's this 30, 60, 90 triangle, and the lengths are 2, 1, and root 3. So you know what? The cosine's pretty easy. It's just 1 over 2. Well, that's just 1/2. Pretty easy. Similarly, someone might say, what about the sine of 60 degrees as an exact number? And that's the key word. This one, it wouldn't have made much difference because 1/2, you would have got 0.5 if you just went cos 60 degrees on your calculator. But you're not going to get an exact value off the calculator for the sine of 60 degrees. So that one we would use our special triangle and go, well, that actually is root 3 over 2. And that's exact. Okay. So that's what these triangles do for us. They give us exact values of certain angles. And of course, it only works for 30, 60 type or 45 degrees. But we do actually have a few others that we can figure out as well. So let me clear the screen, and I'm going to move it up to our next example. Suppose we wanted to figure out the cosine 210 degrees. And it has to be exact. Okay, so how are we going to do that if we can't just punch it into the calculator? Well, this is where the reference angle stuff kicks in. Okay, if I draw a picture of this 210 degrees, 210, so I'm going to go past 90, past 180, down to about here. So there's my 210. So I have to go, well, what's my reference angle? I mean, what would be this little triangle that I'm building here? My reference angle, this is 180, so I would have gone 30 degrees past that. So, hey, wait a minute, this looks like a 30 and 90, so this is 60 down here. So isn't this really just the same thing as our first special triangle? Okay, so I'm going to use this one here. And it gets a little tricky when you orient them differently, but if you're careful, it should work perfectly. So all I got to do is determine that if I'm using a reference angle of 30 degrees, so let's go over here, 30 degrees, cosine would be root 3 over 2. So I know that numerically that's my answer. The only question is, maybe it's gone negative on me. Now there's two ways to deal with that. You can either sketch out your special triangle and put in the negative labels and say, you know what, because we've gone to the left here, we would consider this to be negative root 3, and we'd consider this here to be negative 1, and the hypotenuse we would just leave as positive 2. That takes care of the negative issue, so you'd look at it and say, oh goodness, the cosine is negative root 3 over 2. So the answer is actually negative. Or, if you don't want to think that much, just use the cast rule. Cast rule says only tangent would be positive in this quadrant. So I could just do that and say, you know, I know it's going to be negative just because of the quadrant that we're in. So that's what the special triangles do for you. Now, let's do maybe one more example here, and then I'm going to take a break from this. Let's say we wanted to figure out, let's see, tangent of 120 degrees. Okay, so let's get a picture going. Let's see where we're at. Okay, so 120, so I went past the 90, a little bit past the 90, so roughly here. Actually, let's see if I can do a straighter line for that. That was, okay, not too bad, I guess. So there's my 120. And when I build my little right triangle here, I see the reference angle is 60. So I go, oh, that's my special triangle again. There it goes again. Okay, this time I'm building from the 60 degrees. So let's see if we can figure out what the tangent is. What is the tangent of 60 degrees? It's root 3 over 1. So that's just going to be root 3. Should it go negative? Well, maybe I'm going to use the cast rule for a quick reference. Oh, yeah, only sine is positive. So this is tangent. It better be negative. And there's my answer. Now, that's where I'm going to stop, and we'll come back in a little while.